Alright, good day everyone. So you're welcome back to our channel. So in the last class, I talked about the mean value theorem and I solved some examples, some past questions. So today we're going to go further, evaluating more and more examples and problem solving exercise of the mean value theorem. So I'm going to start with our first question. This is going to be problem solving. We've explained the concept of the mean value theorem. So let's start with our first problem. So first problem states that provided that the function f of x provided that the function f of x is equal to x squared plus 1 is equal to x squared plus 1 divided by x plus 1 at the closed interval of 1, 2 satisfies the mean value theorem. Find all possible values of c. So the first thing which we need to do here is to write out the general formula of the mean value theorem. So we're going to say f prime of c be equal to f of b, f prime of c be equals to f of b minus f of a over b minus a. Then the next thing to do is to find what will be f of c. So it's very simple. F of x is equals to this rational function, so f of c is going to be equal to this is c squared plus 1 over c plus 1. Now the next thing to do is to find f prime of c. So let's find f prime of c. If this is f of c, f prime of c is simply the first derivative of the function f of c. So f prime of c, to find this is a rational function, so we're going to be using the quotient rule of differentiation. So we're going to call the numerator u and we call the denominator v. So the formula states that, I don't know if you've forgotten this, the formula states that for a rational function we have that v du dx minus u dv dx over v square. So this is the formula for the rational functions. That's the quotient rule. So let's implement this formula. So this is v, this is u. Now the idea is that drop v. Let's use it in the layman's idea. Let's not go into a more complex structure. So step 1, drop v. What is v? V is c plus 1. So we're going to drop v, c plus 1. And what is du dx? Du dx means differentiate u in respect to x. And if we differentiate u in respect to x, but now this is in respect to c, so let's be very careful here. Differentiate u in respect to c, we're going to have 2c. We're going to be having 2c. Then minus, what do we drop? We drop u. What is u? U is c squared plus 1. And what do we differentiate? We find dv dc, that is differentiate v in respect to c, and that is going to give us 1. Then we divide all of these by v squared. This is v, so we divide all of these by v squared, and this is going to be c plus 1 This is going to be c plus 1, c plus 1, or what? All squared. So let's dive down to evaluate this. So evaluating this is going to give us, this will multiply with c and this will multiply with 1. So this will give us 2c squared plus 2c. Then here for this part we have minus c squared minus 1, and all of this is divided by c plus 1 all squared. All of this is divided by c plus 1 all squared. So the next thing to do, let's evaluate the numerator. So evaluating the numerator, I have like terms. I have 2c squared, I have c squared. So we'll bring them together, and 2c squared minus c squared, that is going to give us c squared. So c squared plus 2c, c squared plus 2c minus 1 divided by c plus 1 divided by c plus 1 divided by c plus 1, or what? All squared. And we're going to stop here evaluating. We're going to stop here evaluating. So let's call this our f prime of c. Let's stop here. Let's call this our f prime of c. So now let's find f of b. Let's find f of b. So f of b, this is our equation. This is where we started from at interval of 1, 2. So f of b is simply going to be, b is 2. Let me outline it here. B is 2. B is equal to 2. Y, a is equal to what? A is equal to 1. So what is going to be f of b? F of b, putting back into our formula, that is our equation, putting this back into this first equation which we had here, f of b is going to be 2 squared plus 1 divided by 2 plus 1, and f of b is going to be 5/3. F of b is going to be 5/3. Then what is going to be f of a? What is going to be f of a? So f of a is going to be equal to 1 square, we'll put in 1 square plus 1 divided by 1 plus 1, and this is going to give us 2/2, which is 1. Now, so let's implement using our mean value theorem general formula. F prime of c is equals to f of b minus f of a all over b minus a. So implementing using the mean value theorem formula, what is f of c? F prime of c. F prime of c is equal to, let's work on this. F prime of c is equal to c squared plus 2c minus 1 divided by c plus 1 divided by c plus 1, or what? All square. Now what is f of b? F of b is equals to 5/3. F of b is equals to 5/3. Then what is f of a? F of a gave us 1 minus 1. Then b minus a, what is b minus a? B minus a is 2 minus 1, and that will give us 1. So let's carry on solving this. So carry on to solve this. We're going to have this to be, this is still the same thing as c squared plus 2c. It's the same thing as c squared plus 2c minus 1, c squared plus 2c minus 1 divided by c plus 1 all squared divided by c plus 1 all squared, and this is now going to be equal to everything over 1 is just going to give us 5 over 3 minus 1. So we should just focus more on evaluating 5 divided by 3 minus 1. So what is that going to give us? 5 divided by 3 minus 1. This is going to give us 2 over 3. This will give us 2 over 3. So proceeding, we can now cross multiply. So cross multiplying, we're going to have that 3 into c squared plus 2c minus 1 is equal to 2 into c plus 1, or what? All squared. Because multiplying, we'll have this, and we're going to have 3c squared. We're going to have this to be 3c squared sorry, I think I had a glitch. We're going to have this to be 3c squared plus 6c minus 3 is equal to 2 into c plus 1 or what? All squared into c plus 1 all squared. Now we can, from this point we are going to, there are two things which we can actually do here. Either we go through the easy way, or we go through some shortcuts. So I'll see if it can be possible for me to show you both, but let's go through the longer process. Let's evaluate this brackets which is here. So I'm going to have this to be 3c squared plus 6c minus 3, and this is going to be equal to, opening this bracket by 2, I will have this to be 2c squared plus 4c plus 2 plus 4c plus 2. And let's bring like terms. So I have 2c squared, I have 2c squared, I have 6c, and I have 4c, I have negative 3, and I have 2. So bringing like terms, we are going to have c squared plus 2c minus 6 is equal to 0. And now we are going to apply the general quadratic equation here, which says minus b, the plus or minus the square root of b squared minus 4ac divided by 2a. So evaluating this is going to be minus 2 plus or minus the square root, minus 2 plus or minus the square root of 2 square minus 4, multiplying a is 1, multiplying negative 5, and all of this is divided by, this is ABC, A, B, and C, so we don't get confused. This is ABC. So this was supposed to be 6, sorry, it was supposed to be 6. So this is going to be all of these divided by 2, and we're going to have minus 2 over 2 plus or minus the square root of 20. I think let's go back here. Let's see here. This is negative 3 and 2. I made an error here. This was supposed to be 5. Sorry. This was supposed to be 5. Sorry for that. and this is going to give us the square root of 24, the square root of 24, and this is also still going to be divided by 2. So we have minus 1 minus 2.449, or we are going to have minus 1 plus 2.449. So we have two values of C right now here. So we have to pick which one satisfies our interval. So our interval is 1, our interval is 1, 2. So between 1, 2 we have between 1, 2 we have, all of this is going to give minus 3.449, or 1.449. So this is going to be our value of C. This doesn't fall within that interval, so we are going to say that C is equals to 1.449. So I took time to explain this because the question had so much complexities. So we started from differentiating using quotient rule, then we evaluated, we did some algebra, then we bring in the general quadratic formula, then we evaluated down here. So let us take one more problem before we call this video to an end. Let's take one more problem. So let's look at the trig function. Let's take a problem involving the trigonometry function. So provided that we have a function, so the next question from the past question, I will send the past question to, you can download the past question from the link below. So the next question says that provided that the function f of x, I'm going to outline it here for you, provided that the function f of x, where the function f of x is equal to sine x, at interval 0, pi. Find all values of c that satisfy the function f of x. So the first thing we need to do is to find f of c. So what will be f of c? F of c would be equal to sine c. So you can say f of c is equal to sine c. Then we need to find f prime of c, but let's outline the mean value theorem formula, which says f prime of c is equal to f of b minus f of a over b minus a. This is the formula. You need to keep this formula with you, over b minus a. So what is f prime of c? F prime of c is the first derivative of sine c, and that is going to be cos c. F prime of c is going to be equal to cos c. So what is going to be f of b? F of b is simply putting pi into sine c. So if we put in pi, this is a, this is b, this is interval of a, b. You're putting pi into the value of x, then we're going to have this to be sine pi, and this is going to give us 0. It's going to give us sine pi, or we can say sine 180 because pi represents 180. This is going to give us 0. Then we could also see f of a is going to be equal to the sine of 0. F of a is going to be equal to sine 0, and this is going to give us 0. So now we need to find b minus a. What is b minus a? B minus a will be equal to pi minus 0. B minus a will be equal to pi minus 0, and this is going to give us pi. B minus a is going to give us pi. So putting everything, just juxtaposing all of them into the general formula, we're going to have that cos c is going to be equal to, cos c will be equal to 0 minus 0 divided by pi, and we're going to have that cos c will be equals to 0 over pi. So we're going to have that cos c will be equal to 0 divided by pi, 0 over pi. So, and this is going to give us 0. So we're going to have that cos c is going to be equal to 0. So now we can see the cos inverse of c, is equal to, the cos inverse of c is equal to 0. So therefore, is equal to the cos inverse of 0 is equal to the cos inverse of 0. Cos inverse of c is equal to the cos inverse, cos multiplied by the cos inverse of c is equal to the cos inverse of 0. So we inverse all sides. So this is going to go, and we're going to have c is equal to the cos inverse of 0. And now the cos inverse of 0 is going to give us 90. So we can say that c is equal to 90, and we can express 90 as pi over 2. As pi over 2, because pi is 180. So therefore we can say c is equal to pi over 2. So remember that pi is 180, and 180 over 2 should give us 19. So c is equals to pi over 2. So, and pi over 2 exists at the interval of 0, pi. Pi over 2 exists at this interval. So that is that for this very simple trigonometric equation. So let's talk about the Rolle's theorem. So the Rolle's theorem, let's erase this. The Rolle's theorem is an extension to the mean value theorem. The Rolle's theorem is an extension to the mean value theorem. So the Rolle's theorem added another condition to the mean value theorem, which I have here. The Rolle's theorem added a third condition, which states that f of a must be equal to f of b. F of a equal to what? F of b. That is the third condition which the Rolle's theorem gave. F of a must be equal to f of b for the function of f of x. So therefore, we can say that if f of a is equal to f of b, it is said that f prime of c is going to be equal to 0. So this is the fundamental equation. This is the fundamental formula, fundamental general equation of the Rolle's theorem. This is the fundamental general equation of the Rolle's theorem. So f prime of c equals to 0. So let us have a simple equation to actually analyze this. So I have a problem here from the past question. I will send the past question so you can also join me evaluate problems like this. So from Union past question 2015, we have a problem that says the equation below satisfies the Rolle's theorem. Find all possible values of c. So this is the equation f of x. This is the equation f of x is equal to x squared. F of x is equal to x squared minus 4x plus 3. Minus 4x plus 3. And we have the interval of 1, 3. We have the interval of 1, 3. So let us find f of a. Let us see if this really satisfies Rolle's theorem. So Rolle's theorem says that f of a must be equal to f of b. So what will be f of a? If we put in 3 inside this, if we put in 1, that is a is 1 and b is equal to 3. So when we put in 1 into this, we're going to be having 1 squared minus 4 into 1 plus 3 minus 4 into 1 plus 3, and this is going to give us 0. So f of b, what would be f of b? F of b is going to be equal to, we're going to bring in 3. This is going to be equal to 3 squared minus 4 into 3, 3 square minus 4 into 3 plus 3, and that is going to give us 0. So we can have that f of a is equal to what? Is equal to f of b. So f of a is 0, f of b is 0. So this is satisfying Rolle's theorem. So therefore, we can say that f prime of c is equal to 0. So for instance, why can we say f prime of c is equal to 0? So let's say, even using the general formula of the mean value theorem, let's say if we try to implement this using the general formula of the mean value theorem, we have that f prime of c is equal to f of b minus f of a over b minus a. So in this problem we're going to have that, for this problem we're going to have that f prime of c would be equal to, what is f of b? F of b is 0. And what is f of a? F of a is also 0. And what is b minus a? That's 3 minus 1, that is 2. So at the end of the day, we are still going to have that f prime of c, we still result to what? We still result to 0. So let us solve directly. So what is f of c from the equation which I've given you here? If f of x is x squared plus 4x plus 3, what is going to be f of c? What is going to be f of c? So we're going to have that f of c, this is f of x. From what we've done so far, this is f of x. What is going to be f of c? F of c will be equal to c squared minus 4x plus 3. C squared minus 4x plus 3. So now if you find the first derivative of this, which is f prime of c, the first derivative of this f prime of c is going to give us 2c minus what? Minus 4. And now from Rolle's theorem, we said that f prime of c is equal to 0. So therefore, I forgot to erase this. So therefore, we can say that 2c minus 4 is going to be equal to 0, and we can say that 2c is going to be equal to 4. Then we can divide all sides by 2. So dividing all sides by 2, we have that c is equal to what? C is equal to 2. And looking at the interval of 1, 3, we have 2 existing in this interval in between 1, 3. So I hope you've understood the mean value theorem very well. You have proper understanding on this topic, and you can actually solve problems related to the mean value theorem. So see you in our next video. Do well to study hard. Take care.